Hello and good afternoon, everybody. I just wanted to welcome you all to our webinar this afternoon for pre-hospital medication dosing errors with Dr. John Hoyle. Just wanted to go over a few housekeeping items first before introducing our speaker and turning it over to him. As you may have noticed, all the participants have been muted upon arrival into the webinar. This just helps cut down on some of the background noise that often accompanies webinars so that we can record and there's no distraction to our speaker. If you have any questions that you want to submit to me or to the speaker throughout the webinar, please feel free to use the chat box or have a discussion with each other. That's what it's there for. We definitely encourage that communication amongst our participants. And if you want to wait until the end, some people prefer to speak to the speaker directly, I will unmute everybody after Dr. Hoyle's presentation so that way you can ask your question as well. Just a heads up, the webinar will be recorded today, so that way we can host this on our website for people to view in the future. That's why everybody has been muted upon arrival, so we appreciate your patience with that. Also, we are offering a 1-hour CAPC credit for this webinar. At the end, you will see a link in the chat box. Just go ahead and click on that link. It'll be a basic sign-in where we will collect all the information that we need to provide that CAPC credit. If for whatever reason that link does not work or you need help or assistance, please feel free to ask me. My name is Cassidy. You can reach me at the chat box or just get my attention on the webinar. All that being said, it is my thrill and my pleasure to introduce today's speaker. Dr. Hoyle is a professor of emergency medicine and pediatrics and adolescent medicine at Western Michigan University School of Medicine and the Associate Medical Director for Pediatrics for the Kalamazoo County Emergency Medical Services Medical Control Authority. He completed a combined emergency medicine and pediatrics residency at Indiana University. He has board certifications in emergency medicine and pediatric emergency medicine. He spent 10 years as a researcher in the Pediatric Emergency Care Applied Research Network, or better known as PECARN, and has published research on pediatric EMS issues with a specific focus on medication errors. Dr. Hoyle is the principal investigator for an EMSC Targeted Issues Grant, the Michigan Pediatrics EMS Error Reduction Study, or MI-PEERS, and the goal of the study is to introduce a drug dosing safety system across 8 EMS agencies to significantly reduce pediatric medication errors and enhance both pediatric and adult patient safety. So on behalf of the EMSC, we just want to thank Dr. Hoyle for his time and expertise, and I will go ahead and give the webinar over to him. Thank you very much.
The opportunity to address everybody on this topic, so we'll get started. There we go. I do have a conflict of interest to disclose. I'm the recipient of the EMSC grant for implementing a pre-hospital pediatric drug dosing safety system, as Cassidy mentioned. I'm also the inventor and hold the U.S. patents on 2 drug dosing devices, but I receive no royalties and have no royalty arrangements for those. And because of the grant, I have this grant disclosure information I have to put up for you. So you're pretty much heard the introduction for what I do. I'm also an EMS physician, and I do field response. So I'm out in the field on a regular basis, working side by side with paramedics. And as Cassidy mentioned, I'm an EMS researcher, and my emphasis is on pediatric medication errors. But I'm also the father of a child who is on the receiving end of a medical error in a children's hospital. And I'm also a doctor who's made dosing errors. And I've made other errors as well. And the thing I mentioned that is to emphasize that we're all human. We all make mistakes. And we have to get past the fact that human beings make mistakes and start focusing on the systems that the humans work in. So the goals of this, I hope you'll understand the prevalence of pediatric pre-hospital drug dosing errors, and then understand why pre-hospital pediatric patients are at high risk for those errors. And by the end of this, I hope you'll be able to cite common points for errors to occur and be able to discuss tools and systems you can use to decrease those errors. So let's start with a real-life example. There's a 6-year-old with a peanut allergy who ingests a cookie containing peanuts at a friend's house and develops anaphylaxis. The friend's mother calls 911, and on EMS arrival, the patient has hives over his entire body, and he's audibly wheezing. His vital signs are pulse 160, blood pressure 72/40, respiratory rate of 30, and a SAT of 88%. The EMS crew makes the decision to give epinephrine, and it's been 16 months since their last critical pediatric patient and a year since they last took PALS. Crew has difficulty finding the Broselow tape, but they eventually do. They measure the patient, determine that he's 22 kilograms, and give the patient the dose listed on the Broselow tape for 1 to 1,000 epinephrine. The Broselow tape is the only reference that they use. 2 minutes later, the patient becomes unresponsive and is in VFib or VTAC. An IO is placed and a dose of 1 to 10,000 epinephrine is given if the patient is defibrillated successfully. The crew transfers the patient to the hospital. They get little feedback from their care for the patient. And afterwards, the crew is writing the report, and they realize the dose of 1 to 1,000 epinephrine on the Broselow tape is the endotracheal dose for cardiac arrest, 10 times which should be given for anaphylaxis. The anaphylaxis dose isn't listed at all. The error goes unreported, and the system continues on without addressing this critical problem. So I would start off by asking people to think about how many people are aware that the anaphylaxis dose for epinephrine is not listed on the Broselow tape. And because of that, we've actually given people a tool that it sometimes can actually be dangerous to use. So just as a way of background, children are especially vulnerable to drug dosing errors. And it's well known that drug dosing errors occur throughout the hospital-based healthcare system at a rate of up to 18%. And the question is, what's the prevalence of drug dosing errors in pediatric patients cared for by emergency medical services? So Dr. Amy Kaji published a study in 2006. It was done in LA County, and they looked at the children in cardiac arrest who got epinephrine from 1994 through 1997, and they found that 66% of those doses were incorrect. But they also found that fewer errors were made when the Broselow tape was used. Following that, they launched an extensive quality improvement program to decrease errors, which included using the Broselow tape, drug dosing charts that had doses in milligrams, in contact with medical control after the first dose of epinephrine was given for all pediatric arrests. And then they remeasured the epinephrine dose error rate from 2003 to 2004 and found that it had decreased to 35%. I think we can all agree that's a very laudable accomplishment. They were able to cut the error rate in just about half. But I think we can also agree that a 35% error rate means there's still a lot of room for improvement, and there are other things in play that had yet to be identified. So colleagues of mine here at Western, Dr. Lammers and Dr. Thales, published a couple studies, and they had 132 paramedics go through simulated pediatric patient scenarios using high-fidelity patient simulators, and they had a cardiac arrest case, an asthma case, and a sepsis scenario. And they found that epinephrine dosing was incorrect in 68 to 73% of the cases. The Broselow tape was not used in 50% of the cases, and when it was used incorrectly about half the time. So those two studies are two of the very few looking at pediatric pre-hospital medication errors at the time. And myself and some co-investigators did another study to try to identify the prevalence of drug dosing errors in pediatric patients treated by EMS. So we use the Michigan Emergency Records Management and Information Database, or MERMAID, and this is pre-NEMSIS. And this was from January 2004 through March 2006, and we looked at data from 8 EMS agencies. They served about 10% of Michigan's population, or a little over 1 million people. And we looked at children who were 11 years and younger. We looked at scene runs and inter-hospital transfers. And we excluded people or patients that they didn't have a documented weight or a Broselow tape color in their record. So we used our standards for the correct drug doses were based on Michigan's model EMS pediatric protocols. So Michigan for a long time has had standardized patient protocols for EMS. And we defined an error as a greater than 20% difference in the dose from the protocol standard based on the patient's documented weight or Broselow tape. So if the error was less than 20%, we didn't even count that as an error. So this chart shows the patient encounters. So there was a total of 163,000 patient encounters for all, both adult and children. 10,566 of those were children, or about 6.5%. And then about half of those were children under 11. 267 of those received drugs, and we had to eliminate a few because there was no weight documentation, or because the weight was greatly outside of the range that we would expect for age. And that left us with about 230 patients. So once we do the math, pediatric patients who received drugs were 0.14% of all EMS encounters, which makes this a really low frequency and therefore high risk event. For those patients that were under 11 years of age, the mean age was 3.8 years, and 43% of all the drug doses were incorrect. Other findings that we discovered, 69% of the paramedics did not administer a drug to a pediatric patient during the entire study period, so that was 2.25 years. If they did administer drugs to a patient, the average number was about 2.7. And we found that Broselow tape use wasn't documented in 28 out of 230 cases, or 12%. So this chart shows the drug on the left, the number of incorrect doses and the total doses, and then the percentage incorrect on the right. So I'm going to briefly go through this. So for albuterol, the doses were incorrect 23% of the time. And that's a little concerning because this was a standardized dose across the entire patient population of 2.5 milligrams. And all they had to do is just break open the vial and dump it in. And I'll address this a little more when we talk about overdoses and underdoses. Dextrose, interestingly enough, was only administered 4 times, but it was incorrect 50% of the time. And if we look at IV doses or IO doses of epinephrine, 55% of those doses were incorrect. So this goes over overdoses. So again, the drug's on the left, the number of overdoses is in the center, and the mean error for the overdoses on the right. There was 1 overdose of albuterol, and it was 200% or 2 times of what the correct dose was. Probably not harmful. There was 1 overdose of dextrose, and it was, again, double what it should have been. And there was 1 overdose of epinephrine, and that was about 1.6 times of the correct dose. Now, if we go to underdoses, things are a little more interesting. There were 54 underdoses of albuterol, and when it was underdosed, it was about half of the correct dose. So if you have a kid in status asthmaticus or with severe asthma, we give relatively low doses of albuterol to begin with. Giving half of that probably would not be as effective as giving a correct dose. There was 1 underdose of dextrose, and it was about half of what it should have been. There were 10 underdoses of epinephrine, and those were roughly 13% or of the correct dose. So that's basically a decimal point error. And instead of giving like 0.3 milligrams, it was 0.03. So in California, they found that the Broselow tape did make a difference, and we were interested in that as well. So we looked at doses on the Broselow tape that actually had their doses listed in milliliters, and that's only 2 drugs, atropine and epinephrine. So for atropine, using the Broselow tape appeared to make a difference in helping paramedics be more accurate in their drug dosing, but that was not the case for epinephrine. So now we're going to switch gears and talk a little bit about medical errors in the hospital. The first big report on errors in medicine came out in 1999 from the Institute of Medicine, or the IOM, and that was preceded by some significant articles in big medical journals that demonstrated a few things. 3 to 4% of hospital patients are harmed by the healthcare system. 7% of hospital patients are exposed to a serious medication error. And there were an estimated 50 to 100,000 deaths per year from medical mistakes. And that's the equivalent of 280 747s crashing in a year with no survivors. So you have to ask yourself the question, if that was the case, would you ever fly on commercial aviation? And if you compare that with the fact that from 2002 to 2005 and 2007 to 2008, there were no deaths in commercial aviation from crashes. And then from 2009 through 2016, there was not a single death that occurred on a U.S. certified passenger carrier anywhere in the world. So that's a very laudable safety goal, and we should try to emulate that in medicine as well. So despite that, here's an article from the Wall Street Journal just 2 years ago that again points out that 5 to 27% of medication orders for children still involve errors 20 years later. So what happened after the IOM report? Well, medicine looked to high reliability and safe organizations for help, such as commercial aviation, nuclear energy, the military, and even wildland firefighting. And high reliability organizations are ones where an error can lead to a disastrous outcome, such as the crash of an airliner or the malfunction of a nuclear power plant. Those organizations have crafted safety systems and a culture of safety successfully to prevent accidents or incidents from happening. So as an example, you see a photo of a Black Hawk helicopter on the right. In the 1980s and 90s, the Army was crashing a lot of Black Hawks with the obvious results of loss of life and loss of highly trained and expensive individuals. So they went to work analyzing the problem and have found that lack of communication among the team members was a huge component. They redesigned the communication system. They encouraged better crew-crew interaction, and that dramatically improved safety. They then took this step further and applied the same process to emergency room personnel in a project called Med Teams, and they saw an increase in safety and efficiency there as well. So the definition of a high reliability organization is one that functions in a hazardous, fast-paced, and highly complex technological system, error-free for long periods of time. So they have a preoccupation with failure. They realize that humans are part of the system and humans will always make mistakes, and they put systems in place to try to intercept those. They have a culture of safety that's exceptionally important. They have a widely distributed sense of responsibility and accountability, and it's typically reflected as the individual is 100% accountable for their actions, but they're also 100% accountable for their team members and holding them accountable. They have continuous personnel training, and they have redundancy in a variety of checks and counter-checks of safety systems that are put in. So how reliable is EMS when giving drugs to children versus commercial aviation? So you've probably heard of 6 sigmas, and this is a measure of reliability used in manufacturing and business. If you're functioning at the level of 6 sigma, you have reliability to 6 decimal points. So put another way, it means the organization has 1 error in every 1 million events. If we applied that to drug dosing for EMS, it would mean that 1 drug dosing error was made in every 1 million doses. And we're going to talk a lot more about pediatric medication dosing errors a little further on, but currently that rate's about 43%, so that's not even 1 sigma. But when you look at commercial aviation, they're now very beyond 6 sigma. So there's some quotes that I think help sum up the problem. And one of the medical mistakes are merely human mistakes committed within a human system that's inadequately designed to catch and neutralize those mistakes. And W. Edward Deming's a famous statistician, and a quote from him is that every system is perfectly designed to get the results it consistently achieves. So what is a system? Well, that's everything that we do to deliver care to a child. So that's training, continuing training, any and all of the tools that you use or don't use, how your drugs are packaged, and how your drugs are even placed in your drug bag. So every step in care is a part of the system. But our current system and our culture of EMS are perfectly designed to achieve an error rate of 43% for all pediatric drug doses. And that's just not acceptable, and the system and the culture need to be changed in order to decrease these errors. So this is a model put forth by Dr. James Reason. I'm sure a lot of people are familiar with it. It's how errors occur and how barriers or systems can prevent them. So the cheese slices represent systems in place to prevent or trap errors. And you should have multiple systems or barriers in place to prevent an error from getting through untrapped, because not every single barrier is 100% effective. So the arrow represents an error. And in the event that all the prevention systems fail, the error gets through, and in our case, it'll reach the patient. And now not all pieces of Swiss cheese are the same. Some have very big holes, i.e. they're not very good at trapping errors, but they're still helpful. And some are more like baby Swiss, so they have very tiny holes and fewer of them, and those are very good at trapping errors. But unfortunately, in EMS, we don't have multi-layered systems like this in place. So this is just an example of a simple example of a faulty system I saw recently. So this signs up in a bathroom saying that the water in the building is temporarily unsuitable for drinking or consumption. And then we walked around the corner, and there's a water fountain supplied by the same pipes that you can just hit the button and turn on. So this is kind of a system that's perfectly designed for disaster, when the most effective way, instead of putting a sign up, which frequently I think we all know get ignored, is to turn the water off at the source. So what happens, or what kind of safety systems are in place for a drug dose to get to a patient in the hospital? So when I'm in the emergency department, I use a computerized physician order entry program. And before I even see the patient, that computer has checked that the entered weight is appropriate for that patient's age. If it's not, it'll throw out a flag, and hopefully the person entering the weight will recheck it. It also will calculate doses for weight, and it checks the dose against the child's weight to ensure it's correct. That order, if it's a drug that goes to the pharmacist, they'll also check it, and they'll mix the drug. The drug gets barcoded with the patient's name or drug dose, and then when the nurse picks it up, she scans the drug and the patient's ID band. The scanner will confirm it's the right drug and the right patient, and then the nurse will double-check the patient's name and the drug. So this is a screenshot of a dose calculator that I use on a regular basis for morphine. And you'll see it does the math for me. It takes the math out of my hands and sends it through straight to that scanner that I mentioned. So if it's a code or an emergency, obviously a lot of those things can't happen. So what we do is we use the Broselow tape to determine the patient's weight, and we use that only for determining the weight. And the second person confirms that that measurement's correct. We then pull out a code sheet for that weight, gives all of our drug doses in milliliters, and we have a second person confirm that it's the correct sheet, that the drug concentration and volume are also correct. The pharmacists frequently are there with us, and they can draw up the medication, and the drug, the volume, the concentration, allergies are all confirmed by a second person. And then at the end, the doctor, the nurse, and the pharmacist do one final check back, and then the dose is delivered to the patient. So we have to how many checks that is, and that's about 8 or 9 checks that are independent to make sure the dose is correct and that the correct drug is to the patient. So what happens pre-hospital? Well, you have a paramedic that determines the drug needs to be given, and then a paramedic determines the patient's weight. They'll then calculate the dose, and they may do that with or without a calculator. They may consult the protocol, or they may use a drug dosing aid like the Broselow tape. They'll then draw up the dose or grab a preloaded syringe and then administer the drug. So how many checks or error prevention systems are there? It depends on how stringent you want to be in your definition, but if it's a paramedic who has an EMT basic partner and they don't have someone who can actually check their work, then it's probably 0, or maybe at best 2. If you check yourself, it's not a highly valid check. And you think of how many of us have checked ourselves on something and still been wrong. So in order to deliver the correct amount, you first have to have a correct weight, then multiply that by the correct dose to get the correct amount in milligrams. But since we don't deliver solids typically to the patient, we then need to convert this to milliliters by dividing by the concentration and then squeeze out that volume to the patient. So an error at any one of these arrows will result in the patient receiving the wrong amount, which may or may not be harmful. The question is, how often does a paramedic get to do this? You remember from our previous study that almost 70% of the paramedics didn't administer a drug in 2.25 years to a pediatric patient. And then how often did they get to practice this? And in our interviews with paramedics, we find out that it's exceptionally rare in training for paramedics to be able to put their hands on actual drugs, draw them up, and actually practice administering them. Then you put that along with you're doing this under the most stress you could be under. Dealing with a sick or critically ill child is definitely one of the most stressful incidents for any healthcare provider. You have parents and caregivers that are stressed, and then frequently for paramedics, they're in very poor working conditions. So because you don't do this frequently, you need to practice it frequently. And I like talking about Captain Sullenberger because he was able to pull out the landing on the Hudson. He had actually practiced the water landing in his head on multiple occasions. He also, on his spare time, was a glider pilot, so he was used to unpowered flight. And he also spent a lot of time as a safety trainer for the airline and as a fighter pilot. So this is a fishbone diagram that demonstrates all the errors that can occur when trying to administer a drug to a child. So an error at any one of these bones will represent or will result in the wrong dose being given to the child. In reality, there are many more bones where errors can occur that aren't shown on this diagram. So I want you to kind of keep this one in mind because we're going to come back to it. So with all these issues, it's amazing that any of us could get this right. So the correct dose requires a complicated string of events. You may not see a pediatric patient in more than 2 years. It's a very high-stress situation. Aids such as the Broselow tape help, but they're still not perfect, and we don't have error reduction systems in place. So Western Michigan University has a College of Aviation, and I visited it with my son this past spring because he's interested in becoming a commercial airline pilot. So we were met there by a college junior. His name was Tyler, and he was not an admissions counselor, but he did as good a job of explaining about advocating for his school as well as any of the professional admissions counselors that I dealt with for my other son, who's now a college freshman. At the end of the tour, Tyler took us to the flight line, and we watched college students, many who were just 19 or 20, filling out flight plans electronically. And once the flight plan was filed, the students checked in at logistics. They were handed a key to a Cirrus R-20 airplane that cost somewhere between $250,000 and $400,000. We walked outside with one of the students and were instructed by Tyler not to talk while they were going through their pre-flight checklist and checking the aircraft. When the pre-flight checklist was complete, they got in the airplane and began their takeoff checklist. And then shortly thereafter, they taxied and then took off. The student was gone for 2 hours. They returned and landed, and then the whole process started over again. So I told Tyler at that point, I don't think I'd trust a fourth-year medical student to do that, let alone most of my residents. So the difference there is that safety and how to be safe is emphasized from day one in the School of Aviation, and we need to do the same thing in medicine and in training pre-hospital personnel. And the student there in her right hand, you'll notice that she has an iPad, and that's what they do all their checklists on. And from day one, they're basically taught that you will live or die by using your checklist. So the Broselow tape can be an effective tool, but it has to be used for it to work. And we've already shown a couple places where it's not used very frequently. It frequently gets used upside down. There's a red bar that's supposed to go at the head end, and it still requires a milligram to milliliter conversion or doing math for most drugs, and doing math in emergencies is probably not the best practice. Interestingly, when I talk to paramedics, if I ask them where their Broselow tape is, I usually don't get a very rapid answer. And if I ask them how many of them could actually go out and grab it on their rig right now, I get about 50% of them can tell me where it is. But the writing is still small and it's hard to read. There's a lot of drugs on there that aren't used pre-hospital, and a lot of them I don't even use in the emergency department. Some people get confused and think it's an algorithm, and they'll start administering drugs by going down the list for the indications. And again, the epinephrine dose for anaphylaxis is missing, but frequently the cardiac resuscitation dose is administered instead when it's used as a reference. So in my previous job, we actually developed these code sheets. So we would use the Broselow tape to get the patient's weight only, and then we pull out the book and open it to the weight. This has all of our drug doses in milliliters on the right-hand side, and that way we don't have to do any math in a stressful situation. The problem here is that we're all plagued with frequent drug substitutions, and frequently if that happens, you'll get a different concentration. So that immediately would invalidate the book. But we've tried to even think about doing this with an app, but even for paramedics, the frustrating thing is that even in a single day, if they have to exchange a drug bag, they may have a different concentration of the drug that very day. So it's very difficult to keep up with. And that's a frustration that we should all be talking to our Congress people and the FDA about. If there was something like that happening in commercial aviation, the FAA would probably have the whole fleet grounded and they'd have the problem fixed yesterday. But in medicine, that's somehow just an acceptable thing to happen. So this is the Michigan Medication Emergency Dosing and Intervention cards that were developed in Michigan for paramedics, and they coincide with our model pediatric protocols. You can see they're tabbed at the bottom for both pounds and kilograms, and we'll talk about that in a little bit. If you flip it open, this is the red card. You see the doses are listed on the right for volume, and you'll see with adenosine it lists diluted. You see diluted, that means that the drug has to be drawn up and then diluted with a certain amount of saline, and then you give a fraction of that amount listed in the column on the right. So frequently when we started with this, and I still hear sometimes that paramedics would think that this is a cheat sheet and that it wouldn't look very professional for them to be using those. And when I try to tell them about, pilots do this every day. You get on an airliner and you look in and they're doing a checklist. And that didn't seem to hold as much weight as these two guys using their drug dosing cards every Sunday in front of millions of people. So, Steve Belichick is an exceptionally successful coach. He uses the playbook on the sidelines with millions of people watching him. And I don't think fans or team members question his competence for doing so. Obviously, jokingly at times they would. And then here at Tom Brady, they're opening up his drug dosing card. So what else have we learned lately? I'm going to go over some other research that we've conducted and share that with you. So we published this paper in 2015, and we did a focus groups with paramedics asking them, what is it that's so difficult about giving drugs to kids? They said that their pediatric training, they don't get enough. The training they do get is irrelevant. And most of the time it's PALS. They said the problem with PALS is that it doesn't focus a whole lot on what they do on a day-to-day basis. And in addition, they also said even in their PALS courses, they never actually pull the drugs up, draw them up, and administer them. And that their training for pediatrics is infrequent. They said that drug calculations are difficult and they're error-prone. Their drug boxes are set up for adults with adult doses. And a very interesting thing we found is that they obtain a weight in pounds, but they have to dose in kilograms. So we went in with the assumption that they were using the Broselow tape to get patient weights, and that's the way a lot of protocols are written for paramedics. However, they told us that they would walk in, they frequently would ask the parent how much the child weighed, and if they gave them a weight, that was the one they used for their drug calculations. But then they have to convert that to kilograms. Before we went to electronic charting, on our paper charts, there was a table on the back that would convert pounds to kilograms for them. But with the electronic medical records, that went away. So they had to do math in their head or try to pull out a calculator. They also said they want new and better tools to help them deal with pediatrics. And they said the Broselow tape's helpful, but it's also confusing, and it's frequently kept in a locked drug bag, so they don't get to look at it very often. They said this kind of led to the out-of-sight and out-of-mind phenomenon. So once they actually had a pediatric patient, because they hadn't seen the Broselow tape in forever, they didn't even think about using it. So in 2016, that kind of led us to, since the paramedics are using pounds and a weight from a parent for their drug dosing, and there had been some pediatric emergency medicine research that had showed that that's actually fairly accurate, if not as more accurate even than the Broselow tape. We wondered if we could get 911 dispatchers to ask about patient weights. So we did this study for about a year in Kent County, Michigan. So if you called 911 about a child, the dispatcher would ask, do you know how much the child weighs? And then we compared that weight to the hospital scale weight once the patient got to the hospital. So if you were 8 years of age or younger, we found that those weights were typically fairly accurate. So 80% of the time they were within 20% of the patient's actual weight, and that's an adequate estimate to do drug calculations. So the question is, would having that patient's weight sooner for the paramedic or the EMS crew, would that make their life easier? Would it be less stressful, and would it help reduce errors? And we don't know the answer to that yet, but we're investigating that in our current study. And in 2017, we published a study. We're trying to find out if drug dosing errors with kids was a national problem. It obviously seems to be an issue in Michigan and California. So we conducted this survey through the National Registry of EMTs and found out that 43% of paramedics said they were aware of a pediatric medication error, and that likely represents the tip of the iceberg phenomenon because the number of errors that actually get reported usually are only a fraction of those that actually occur. 51% thought that they could report an error without disciplinary action, but unfortunately that means that 49% could not. And if you can't improve a system without people freely reporting errors that happen and without retribution for those. 60% said their initial training didn't include enough pediatrics, so that's becoming a common theme. 23% hadn't had a pediatric training course in 12 to 24 months. And 27% hadn't given a pediatric patient a medicine in the last 12 months. Now, this probably represents some recall bias because you'll see that when we did our study in Michigan previously, that number was closer to 70% for over 2 years. And 31% reported that they never had any patient safety training. So that brings us to the Michigan Pediatric EMS Error Reduction Study, or MyPEERS. And I have to put in a plug for my co-investigators, Dr. Glenn Blad, Tracy Hover, and Dr. Bill Fales. So this is a 3-year EMS-funded study with 8 intervention and 8 control EMS agencies in Michigan. And we're instituting a 10-item safety bundle for improving drug dosing accuracy. And that includes checklists, frequent mini pediatric training sessions, use of drug dosing cards. Every pediatric case actually gets a quality improvement exam, and then the data we learn from those gets shared among our agencies. We've had patient safety training specific to pediatrics. We've instituted an anonymous error reporting system, and all the data from that system gets shared with all of our intervention agencies. And we have done away with the Broselow tape, and we've introduced a new tape that's for weight only. And then in order to evaluate effectiveness of this, we're using simulation. And the importance of using simulation is that it allows us to actually see every step that happens along the way. And I'll demonstrate in a little bit why that's so important, because we actually find things that we hadn't expected. And then we're also going to look at the Michigan EMS information system, which will let us track every pediatric patient. So I'm going to share with you our preliminary results, and this is on the data that we've done before our intervention took place. But we did simulations. They took place in a mobile simulation unit or a simulation center. The crews that were participating were required to administer drugs as they normally would using their regular drug bag. So they would have to break the locks on them, and if they had to give in a controlled substance, they would draw that up and administer it to the mannequin. We had 4 scenarios: an infant seizing who's also hypoglycemic, a 5-year-old with anaphylactic shock, an 18-month-old with a partial thickness burn, and an infant in cardiac arrest. And again, we defined a dose error as greater than or equal to a 20% difference from the correct dose. We've completed 114 simulations, and you can see the breakdown there. And this is what our crew results look like. So we have a pretty even break between paramedic crews and paramedic EMT basic crews. And you can see the years of experience is fairly well distributed, with about 35% of the participants having at least 5 years or more of experience. So this table shows the drug on the left, the number of correct doses and total doses in the middle, and the percent correct on the right. And I'm going to, now with highlighting, I'm going to demonstrate the dose error rate for specific drugs. So for intramuscular midazolam, in the seizure case, 66% of the doses were correct. Once we go to the second dose of midazolam for a seizure, has to be IV, and it's required that that be diluted. And the accuracy dropped there to 50% correct. For dextrose, it was 63% of the cases were correct, and that was also in the seizure case. For anaphylaxis, 72% of the epinephrine doses were correct. For the burn case, 72% of the fentanyl doses were correct. And for cardiac arrest, 68.5% of the epinephrine doses were correct. So this chart demonstrates the errors made when drugs were diluted. So again, it shows the drug on the left, the number of dilution errors, and the percent of total doses in the middle, and the number of overdoses and underdoses on the right. So for intramuscular midazolam, there were 3 dilution errors, or 11% of the total doses, and those were all underdoses. And midazolam intramuscular is not supposed to be diluted. For IV midazolam, there were 5 dilution errors, or 41% of the total doses. There were 2 overdoses and 3 underdoses. For dextrose, there were 6 dilution errors, or 27% of the total doses, and that's actually 3 overdoses and 3 underdoses. There were no errors with epinephrine for anaphylaxis. There were 3 dilution errors with fentanyl, or 6.8% of the total doses, and that resulted in 1 overdose and 2 underdoses. And then there was 1 dilution error with cardiac epinephrine, and that's not supposed to be diluted, but that was diluted because the crew thought that all pediatric doses had to be diluted, and they actually ended up giving 1/10 of the correct dose. And I think that same error phenomenon carried over to the midazolam above, because intramuscular midazolam is not supposed to be diluted, but there was this perception that all drug doses for kids needed to be diluted, and it resulted in underdoses there. Other things we found is that 5 of the 1 milligram per 10 milliliter epinephrine doses for cardiac arrest were 10-fold overdoses, or 10 times too much. And then an interesting phenomenon that no one's reported previously is that there were unrecognized air bubbles in the administration syringe in roughly 17% of the cases, and that contributed to underdoses. So this included 1 case where the entire 1 ml dose of fentanyl was air. So when the drugs are diluted, they are required to draw up the entire amount from the drug vial into typically a 10 ml syringe, and then dilute it with a certain amount of saline. They then hook a 3-way stopcock to that syringe, and then they'll use that to transfer medicine into a 1 or 3 ml administration syringe. That stopcock typically contains about 0.15 to 0.2 mLs of air. That frequently got transferred into the administration syringe and was not, it wasn't recognized that it was there. For this fentanyl case, the stopcock was turned off to the administration syringe, or the smaller syringe, and the paramedic did not realize that was the case. The paramedic drew back the plunger, and the syringe wasn't seated tightly in the stopcock, and that allowed it to pull up air from around the junction point, and the thing was filled with an entire 1 ml of air, and that was administered to the mannequin. There were also errors of omission, so things that should have happened that did not. And in the seizure case, there was a failure to check the blood sugar in 16% of the cases. If you recall from the database study I mentioned before that we only had 4 administrations of dextrose, and I think a lot of that is because people don't check. And in anaphylactic shock, epinephrine wasn't given for 46% of the cases, and a fluid bolus wasn't given in 40% of the cases. So this demonstrates the drugs before and after Michigan introduced the mimetic pediatric drug dosing reference. So the drug is on the right. The percent correct in the center column shows before the drug reference was introduced, and in the right it shows after the reference was introduced. So for midazolam with seizures, 24% of the doses were correct before the reference was introduced, and that improved to 66% after. For dextrose, 6% of the doses were correct before the reference was introduced, and that improved to 64% after. For anaphylaxis, 24% of the cases were correct before, and that improved to 72% after. And for cardiac arrest, 31% were correct before, and 68.5% were correct afterwards. So I think this demonstrates that the cards were the only major change that really occurred. And I think this demonstrates that the cards do make a difference. They dramatically decrease errors, but they don't eliminate them. So the red circles here represent the arrows that can be defeated or diminished by having pre-printed pediatric drug cards. And you'll see that there are still some things that aren't circled, and those things, as well as others, are still resulting in those around 30% error rate. So the question is about our study is if our safety bundle works, and we don't know yet. Some of the components may and some may not. It's going to take the entire study time, which is 3 years, to determine what works, what doesn't, and what things may make errors worse. And we're going to finish our data collection around September of next year. So the drug dosing cards do seem to reduce errors, but again, they don't eliminate them. So I want to talk a little bit about the law of unintended consequences. And that tends to be the rule, not the exception in medicine. And a person that has espoused this very strongly is Peter Pronovost, who's a critical care anesthesiologist from Johns Hopkins. He's also a tireless pediatrics or medical safety researcher. But medicine's full of good intentioned ideas to reduce errors and improve quality that actually, in the long run, can make things worse. So anything you change can have one or many unforeseen downstream consequences. So anything you want to put in place to reduce errors needs to be thoroughly tested with simulation prior to implementation. You all may recall seeing Apollo 13 when Kevin Bacon, I think Bill Portman were playing astronauts on the ground, and they kept getting into the simulator and running every possible scenario until they found the absolute best protocol for getting the astronauts back. So you have to have a real-life test, and every step has to be carried out. It can't be verbalized. Just allowing someone to say, I would do this, fails to put your fallible human being through the steps that really occur. And that's why simulation is so important, and why simulation allowed us to find things that were going, like pulling air into the syringe. So how do we fix this? Well, paramedics and EMS medical directors need to test systems and technology to help reduce errors, and the effective ones obviously need to be put in action. So paramedics right now do not have the tools needed to perform well with an infrequent event, which is giving a drug to a child. So we need to change the system, but we need to be aware of the law of unintended consequences. And to quote W. Edward Deming again, he has said that a bad system will defeat a good person every time. And simply put, you can have a person who's highly competent, but if you give them a system that is prone to error, those errors are still going to occur. So this really requires a change of our EMS culture. We have to realize that all humans make mistakes. Hauling people into the office and berating them for making those mistakes is not going to change the system. It's not going to make things better. If a paramedic A makes a mistake today within a system, that same mistake or error is going to happen with a different paramedic in a different system or even the same system down the road. So we have to treat errors as a system failure, not a failure of the person that made them, and we have to eliminate blame and shame. Errors need to be freely reported without repercussions so that the system can be corrected, and we really need to design EMS-specific systems to decrease medical errors. We need to get more slices of cheese in the system. One of the powerful things that John Nance mentioned, he's also a pilot and a patient safety advocate, is that he suggests that we treat every drug dose as if it's wrong and it'll kill the patient. And those college students I mentioned previously, the College of Aviation, have a similar mindset. They realize that they will live or die by using their checklists. And that's why they're trained from day one that they must use them every single time. So I'm going to give you some recommendations. Some of these are evidence-based. Some of them are just best practice. And I'll mention which is which. So the first one is that paramedics should look at their pediatric equipment at the start of every shift. That includes their pediatric airway equipment. It includes their IV access and IO access equipment. And it includes any drug reference that they have as well as the Broselow tape. And if that means they have to break open a plastic lock on a bag, then they should do it. In our study right now, we're having that happen. And I'd consider that a best practice. Second thing you need to do is define your agency standard for obtaining pediatric weights. I think it was a real eye-opener to us to find out how the paramedics were actually going about getting weights, and no one had really asked them before. We assumed they were using the Broselow tape and they were not. So you have to define what your standard is or what your hierarchy is. And again, I think that's probably more a best practice because we don't have a lot of evidence on that yet. You need to have a pediatric reference with all doses in milliliters. And I think, as I mentioned previously, the research we've done has shown that that does reduce errors. So that is evidence-based. But it has to be standardized for the drug concentrations you use. And again, it may not be valid if you get replacement drugs outside of your system or if there's a drug substitution. Paramedics should check the weight, the drug, the dose, the concentration, the route, and the syringe volume with their partner. There's not any specific evidence in the pre-hospital environment that this makes any difference, but it has been proven to be more effective in the hospital environment. The other thing you really need to do as an EMS agency is start examining all your pediatric calls and give feedback. You can't tell what's going on in your system unless you have data. And then I would say strong consideration needs to be given to eliminating the practice of dilution. Our preliminary findings show that it actually can increase errors, and it has the unintended consequence of drugs being diluted that shouldn't be, that also adds to errors. And I think that's an evidence-based recommendation as well. You can't do well at a rare event without practice. And again, I mentioned Captain Sullenberger, who landed on the Hudson. You need to practice and train and train and practice. So regular, like monthly, pediatric mock codes or cases are important. And you need to give your paramedics the hands-on experience of actually pulling up drugs, using the actual fake drug vials, and those can be purchased from different supply agencies, so you don't have to worry about using real ones. And then when you do those mock codes or cases, include a mini test. Doing mini tests actually helps cement learning. I would encourage your paramedics to do PALS and pediatric protocol reviews weekly. Again, it may be a long time before they have a PEDS case. That needs to be fresh in their mind. And you need to look for positive deviance. When we found that paramedics were asking parents the weight when we thought they were using the Broselow tape, that's positive deviance. The paramedics had developed a system of their own to work around the written protocol that was more effective and actually probably more accurate. And if that's the case, those things we need to implement. So take-home points, the pediatric drug dosing errors occur at a very high rate in the pre-hospital environment, and the contributing factors are inadequate pediatric patient exposure, requiring personnel to do mathematical calculations, infrequent practice of drug administration, and lack of exposure and practice as a setup for errors to occur. There's a lack of error prevention systems in place for EMS, and we have a culture of blame and shame still. So now is the time to begin solving this problem for EMS and pediatric patients, and it'll require unique solutions. So for now, if you're in an EMS system, you should define your standard for obtaining a pediatric weight. You should have weight-specific drug cards with doses in milliliters to remove calculation from the equation. Give strong consideration to eliminating dilution. Improve training by doing just small monthly pediatric mock codes or even cases, and those can be sent out even via email. and encourage paramedics to check their drug doses with their partners. So that's it. Thank you for the opportunity, and I thank you all for what you do every day.
Yes, thank you, Dr. Hoyle. Definitely appreciate the insight. We have about 10 minutes for questions, so I'm going to go ahead and start by moderating a few of the questions that have been submitted through the chat box. And as I do that, I will also unmute the line if you have a question that you want to ask yourself. But please be mindful once I unmute the line to go ahead and mute if you are choosing not to speak. So, Dr. Hoyle, the first question, how did you get buy-in or participation from your EMS services? We offer high fidelity simulation to our EMS services, but staffing and or financial obligations are a big obstacle.
Fortunately, a lot of the EMS agencies that we're working with have worked with us on research previously, so that was helpful. Admittedly, we have had challenges, and one of the challenges we've run into is the staffing issues. A lot of the EMS agencies are stretched fairly thin. So when we have structured it so that like what we're doing now with our mini training sessions, we send those out via a distance learning system. They're designed to be done in 10 minutes, and they have access to that via even their phone. So if they're sitting on station, they can even do them. And we encourage them to do them with their partner. I think for everyone with this kind of issue in training, there's always going to be challenges, and I would be lying if I said we haven't run into some significant challenges ourselves trying to get buy-in. One of the things you have to do is try to identify influence leaders in the agency. So those are people who are early adopters and people who would think the training is valuable and get them to act as your spokespeople. And we had to have buy-in from our management and leadership in the agencies. So our most successful agencies, I can tell you the director basically said, we're participating in this study, and thou shalt do the training or thou shalt work somewhere else. Mm-hmm. And that's been pretty effective. Now with really large agencies, I think that becomes a little more difficult. But that's a challenge that we're still facing every day.
Absolutely. And I know that oftentimes we have the greatest intentions for the simulations, but that can be a very costly and time-consuming resource as well. The next question is, Dr. Hoyle, which drug did you find was the most difficult for paramedics to correctly dilute? Second, were there cases where you found paramedics giving the wrong drug but refusing to believe that they made an error?
Dextrose is very hard to dilute, and I think a lot of places have caught on to that. And I know in Michigan now, and we've switched to just D10W as our dextrose solution, so that no dilution is required. And I think that was a great decision. And the second part of the question was do we ever have a case where a drug was administered and it was the wrong drug, and people still thought that they administered the right drug? And we did. We had a case in the anaphylaxis case where a crew pulled adenosine out of their drug bag. The one paramedic showed it. The other paramedic said, "I'm going to give adrenaline," and the other paramedic said, "Okay." And then they drew up the dose of of adenosine and gave that to a mannequin that was in anaphylactic shock. That's called a 15-15 green error. Again, using the aviation analogy, and that came from a crash that happened in Dallas. I think it was outside of Dallas, Texas. The pilot and co-pilot were heard on the cockpit voice reporter going through their checklist. They have to have their flaps extended 15 degrees before takeoff. And you hear the pilot say 15, 15, and then green. Green means there's a light on indicating that the flaps are extended. The co-pilot says back 15, 15, green. They take off. The flaps were at 0, and they crashed. So that's another thing you have to deal with, the perception amongst crew people.
Yeah, that's fantastic. And just a quick note, too, I did try to unmute everybody's line, but as you guys heard while Dr. Hoyle was answering a question, it was quite a bit of feedback. So we're going to go ahead and leave those muted. So if you do have a question, go ahead and put that in the chat box. But to follow up with that, first and foremost, definitely appreciate kind of like the stories behind the research. I feel like sometimes we get bogged down by the numbers, but you did a great job of really showcasing what those numbers mean in the real-life application. But to that end, are there best practices research that you've found on ways that that communication can improve? So being able to admit that error and being able to do that in a safe manner to where you're not fearful of losing your job or repercussion. Are there literature resources that you can recommend to actually be that advocate?
Well, I think in medicine that's still difficult, and in medicine we've only been at this for 20 years. So I think the best model is still aviation. So the FAA has an anonymous error reporting system. So a pilot at any time, even if they're the one that made the error, they can report it into the system. They're actually given kind of a receipt for that gives them a number. So then if the error is discovered and it becomes a disciplinary issue, they can actually pull out that receipt and say, I did, yes, I made the error, but I also acknowledged it to the error reporting system, and I think that is protective for them. But I think I would hope that at least, I also think that commercial aviation has taken that to the point where they're not going to do that. They're not going to take retribution against those people because they realize they do have a great safety record, and I think it's kind of become a self-fulfilling prophecy, so now they're trying to do everything they can. Like I said, I do not think there's much literature out there, I'd say especially for EMS, but even in the hospital side, that shows that error reporting necessarily has made a huge difference. What it does, it changes the culture. So it actually lets people know that things should be reported, and that starts to change the culture toward, if an error does happen, it gets reported. But that literature, I think, is still kind of lacking, unfortunately.
All right. Well, thank you for that. At this time, just to be respectful of everybody's day and the schedule for the webinar, I'm going to go ahead and extend my thanks again to Dr. Hoyle on behalf of the EIAC. Definitely appreciate your feedback and your expertise and knowledge that you were able to provide to us all. Just a heads up, this webinar is being recorded, so it will be housed on our EIAC website if you want to go back and reference some of what Dr. Hoyle presented today. For those of you who are interested in CAPC credit, there is a link that is going out into the chat box now. Go ahead and fill that out and submit your sign-in information, and I will be in touch with you all regarding how to proceed in getting that credit. There's a lot of things coming in from the audience as far as saying thank you and appreciate your information. So that being said, you all have a wonderful rest of your day, and you should be able to see this webinar on our website within the next 2 to 3 business days. All right. Thank you again, Dr. Hoyle, and everybody have a great day.
Thank you.